top there, and you can see the material dropping down. That pile there represents probably about 2/3 of a day collection. I was there two times in the site, and this is about 2/3 of the way through the process. You notice a bunch of steam coming out. That's coming out of the cyclone, where they collect the fine particles, and we'll show you some more details here in the background here to get some more details on all the different components of this system. So here, just another shot on the one side there. You'll see the white pipe. That's the air intake for the blower, and that blower, just beyond the blower, is where you have the flame and 850,000 BTU heaters right there generating this hot air. At the bottom left there, you can also see there's a structure there in the middle that's dropping down into a hopper. So the separated manure solids comes up an elevator and drops into the hopper, drops down and drops in the hopper into the hot end of this, I guess it's 10-foot long, 32-inch diameter stainless steel roaster. We'll show some pictures of that here in a minute. The other side just shows an opposite view. Again, the white intake pipe for the blower, where it's blowing the air in with the where the flame is and everything else. And you can see some of the piping there related to the gas. Here's a propane tank outside, and it's run off of propane. Here's a better view, closer view of the Roast-O-Matic. It's basically used for soybean drying, and it's a 10-foot long, 32-inch diameter, rotating stainless steel roaster drum. The materials in this particular view are flowing. You can see the elevator come up through in the back there in the corner. You can see the upper right. You can see the elevator coming through, dropping into the hopper, dropping down into the roaster at the flame end, and then it moves from right to left to the other end. The picture in the upper left corner, we open the end up there, and this is a view down into the roaster while it was operating. Of course, all you can see here is steam, because remember, we're sucking all that moisture out of the material there, and all you see is steam. I was there another other vent in a lower picture. You can barely see the middle of it. You can actually see the opposite end, but there's a bunch of I guess fins, whatever. So when that thing's rotating, it's tumbling the material around as it's moving out of the material, so the hot air keeps drying it on the way out. Just some more views. The upper left-hand corner just shows the process where they're moving material from the separator and dropping into the hopper that drops down into the chute, which goes to the roaster. And the bigger view here is showing a bunch of different things. If you look on the right-hand side, where all that accumulated manure solids are, that ends up being the suction flume that's pulled up, and there's a big fan there that pulls a draft on the exit part of the roaster. So you're pulling the air out of at the exit end of the roaster. You're pulling the air just enough to grab the fines, pull them up, and put them into the cyclone. Because what happened is if they didn't have the cyclone in there, they had so many fines come out there. There was all kinds of dust and all kinds of issues. So they had to come up with a method to pull the fine materials that were coming through that system, pull them out of there and run them through the cyclone to drop them out in a different location. And just another close-up view. Here's the cyclone. You see at the very top, that's where going to the left side is the exhaust of the cyclone going out the building. And the cyclone speed is variable speed drive on that motor and on the roaster, the lower left corner there. And they have to match up a little bit because you don't want to suck too fast with the cyclone to affect the flow going through the actual roaster. So there's a little bit of engineering or a little bit of site adjustment there to get that system to work correctly. And this is the bottom of the cyclone where the fines that are collected are spun around and they drop out the bottom. They're still pretty warm, probably over 100 degrees, just about 80 to 100 degrees. I took a measurement, forgot to record it, but pretty warm material coming out of there. The day I was there was about 35 degrees, so generate some steam that day. So the cyclones are a critical aspect of this thing to pull out some fines. And this is the finished pile. So here you get processed manure solids. This is about 1 day's worth of material. The moisture content in this pile runs between 46 and 55%. I took a sample one day and I got 55%. They could make the material drier, but if it gets too dry, when you put it in the barn and you have a ventilation system in your, or a fan moving air in your barn and stuff, it can pick up that dust and it becomes a problem. So you don't want it super dry, but they basically dried it down from somewhere around 70% down to, 40, 50, around 50% is ideal. So they knocked 20% of the moisture out of the material before they got there. And I didn't show a separate picture, but in the background there, you see another pile of material. That would be the manure solids that were not processed to the dryer. So on some days, if they want to keep the 2 days or 2 or 3 days a week, they're not running the system down there, they can just run through the separator and run the manure solids out without drying. And they have the system hooked up, they can do it that way. And they have a pile of separated manure solids that are going through a heating cycle, and they're not green anymore. So they use it on occasion, but they're not using much of that stuff anymore at all, just for maybe dry heifers and other locations. But their key process here is this nice dry pile of material. So here, one last shot is they move the cows out of the section there. You see how they scrape the alleys, and you notice, look at the volume of bedding in these stalls. He overbeds even recycled manure solids, but this guy was in for cow comfort, not having hoof issues. He reduced the mastitis in his operation once he went to this drying system, and a couple other things we'll talk about. But this guy went down through there, 2 or 3 passes on each side. I think he had to do 6 or 7 buckets or 3 cubic yards, about 36 cubic yards a day of this material to bed when they are doing bedding that day. So they really do a super job of bedding the manure solids in the system. So this all, so I had to put this in for potential risks. And of course, we have a large BTO burner going, and the resulting fines can be a fire risk. So you got to look at that kind of situation. There is always a fire hazard when you're heating up materials and doing that kind of thing. The discharge from the cyclone can have some hot ash coming out of it. And initially, they were shooting it straight up through the roof, and they were getting ash on the roof. They didn't like that look of that, and maybe a little bit burning on the, well, it's a metal roof, but still they didn't like that look. So they changed the discharge out the side of the building. And certainly you don't want to be discharged, even with the screen on it. You don't want to discharge into a, I don't know, dry field or cornfield or whatever. Grass areas is much safer. The other critical thing, monthly cleaning. At least once a month, and you saw the buildup material on the outside in the one photo. You have some buildup on the inside of the roaster that needs to scrape out every once in a while. So at least once a month, they spend 2 or 3 hours cleaning off, brushing off, whatever you want to call it, cleaning the system, adjusting it, exposing the motors and those kind of things. Certainly, you don't want to put this operation right inside your barn, your dairy facility, those kind of things. And like I said, over drying the material will cause dust issues within the barn. So we want to dry the material down enough, but not too much. So let's look at the real cost of doing something like this. Hey, this is a great idea, but what's it going to cost to do this kind of thing? So this model 3210 bean roaster is about $65,000. The Cyclone's another $12,500. That multi-function control panel is $1,500. At the time the farmer did this, he paid $3,500 to get all that programming figured out, to have a nice system where he can go up and push a couple buttons and get things going and make sure he has a fail-safe. Then obviously there's some electrical hookups, about $2,000. So we're talking about $84,500 to add this drying system. Now keep in mind, the farmer already had the manure separator, all the elevators, the building and everything else, the support structure around it. We didn't add that cost. This was just the extra cost of going into the equipment cost of going into this drying process. Yearly cost to operate. So he had really kept good records of propane. I think he told me it's about $26 to $29 per day for propane. Remember, we're drying the manure from 335 cows. He has several electric 3-phase motors. I estimated about $650 for electricity there. Labor to check daily. So I figured 20 minutes a day. They fire things out, do quick inspection at, excuse me, $30 an hour, and plus so many hours per month for cleaning. That turned out to be $2,480. Programming updates and checks, once a year, or something goes wrong at the cow, the programmer up to $500. here's a big ticket item. So let's just assume that the producer doesn't have a bunch of money in the bank, needs to borrow the money. So we're going to borrow the $84,500 for 7 years at 8% interest. That's going to cost you about $15,800 per year to pay back that loan. And I assumed here about a 3% O&M, $2,600. So the total annual operating costs, if you had to borrow the money to buy the materials, about $27,400 per year. So what are the direct benefits to the producer? And I should stop at this point in time to say, so the gentleman's Reed Hoover, an older dairy farmer. They're incorporated. His son's Brad's probably doing 90% of the work on the farm, but Reed's still involved on some of the day-to-day stuff. And I asked him, well, what got you inspired to even think about doing this on your situation? Well, Snoops, the bean drying company, is trying to be innovative, and they contacted him several times prior to 2015 when he installed the system, because they were looking at using their roaster for other applications other than beans. And one of their other applications, they've done it successfully but had some issues, was they were actually going into poultry houses and drying poultry litter. Now, they weren't drying the heavy wet cake, but they were taking all the other litter out of the house, running through the roaster and putting it back in. And they said they and independent poultry guys that weren't affiliated with a big integrator said, hey, they were saving money. They could run that litter through that system several times before they had to add new litter. It was saving them money. It was providing better air quality, drier material, better feed production for the chickens and all this kind of stuff. But unfortunately, folks, why I mentioned the fire risk, there was a fire in one of these facilities. Now, it was a back and forth. What caused the fire? Was it Snoop's equipment or was it something else? So that was back and forth. So that's why I had to talk at the risk about fire. But anyway, so the manufacturing company contacted them. They gave them a price. It was way too high. They went back and forth. They finally brought the price down because the company said, we need to demo this somewhere. And they refigured things. And that's how they got to Reed Hoover to put this in. And he is absolutely, totally sees major benefits to this thing. So, number one, 20% reduction in clinical mastitis in cow udders. So he saved at least a couple $1,000s a year in having a vet come out and treat mastitis and those kind of things. They didn't have the specific numbers, but they thought they saved at least 10 cows not getting mastitis, to the point where either the cow would die, which I show here, 5 cows died. They posted them on the farm. That's $2,000 a cow. That's $10,000 of savings right there. They also had probably 5 of those 10 cows. They survived the mastitis issue. They got the drugs out of them. They would ship them to the market, but they were pretty. They weren't on the high end. They were only getting about $800 a cow. Another $1,200 lost. $6,000 there. Improved herd health overall. I didn't know how to monetize that number. Hawking issues were gone. Just a bunch of good things were happening to the whole herd health with this drier bedding material. So that was a big thing. And the next one, and we'll talk about this in the next payment here, somatic cell count. And the folks, if you do anything in the dairy business, you hear about somatic cell count. And certainly most folks that go to the other, sand bedding and those kind of things, they're shooting for 100, 150,000. That's the count they want to get down to. This farmer, with his manure solids and bedding green manure solids, 3 or 4 times a week and doing all the grooming and everything else, he was running around 400,000, which is still, that's still marketable milk and all that kind of thing. But the combination of having a high somatic cell count and mastitis issues, because the cow's udders are laying in a wetter manure, because you always get situations, a couple times a year in southeast Pennsylvania, you get these hot and muggy days for days on end. Even if you spread that manure solids on there very thin, the ventilation stuff just can't dry it out because it's muggy conditions. But combination of things like that. So he had a high somatic cell count, and it went down from 400,000 to 150,000. So that's a big benefit. And back in the good old days, about 5 years ago, most farmers got an extra payment for going from, 400,000 or keeping it at 150,000 somatic cell count. They get an extra bonus payment. But with the COVID, surplus milk, and everything else, no one's getting any bonus payments for the 150,000. But if you're a guy at 400,000 or 500,000 and they want to cut their milk base, you might be the farmer they might be after, not the guy with the poor quality milk. So anyway, here we come up with a number of direct savings of $18,000. So, we had a $27,000 cost per year. I got a direct savings of $18,000. We're still in the hole. So the indirect benefits. Now, this is the thing that was really hard to encapsulate and capture. But, prior to 2015, he had a somatic cell count of 400,000. Now he's down to 150. That's good. I did find two different studies that indicated, like at Ohio State said, that you can milk production will go up 1.2% for every 100,000 drop in somatic cell count. So that's 2.88. You run the math through here. I only used $18 per hundredweight. That's $51,000 of extra income generated by going from 400,000 to 150,000 if somatic cell count was the only thing you dropped and there was no other changes in that operation. Another study by Arkansas came up with 600 pounds, and running through the numbers is $45,000 savings. So you average it out, it's about $48,500. So they're saying that the indirect benefits to going with with reducing your somatic cell count generates a higher herd production and generates you more income. But you have to remember, just like one presentation today, or if you tell a farmer, if you put better lighting in your barn, you're going to gain 3 pounds per cow per day, that kind of thing. So it's hard to say, was this one factor the only thing? But let's take a look at that. So initial cost $84,000. He had an annual cost of purchase of $27,000. With direct savings that we could the farmer could quantify in his mind $18,000. I still had a net loss of $9,400 a year. But I'm saying, based on other studies, you could get anywhere from, maybe 40,000, 48,000 of extra milk production, which you can't really hardly quantify. The other thing the farmer did tell me, he did shift milking from 2 times a day to 3 times a day. So he boosted his milk production probably by 15, 20% right there. So there's a couple things in here that kind of fuzzy math here. But even if I look at the fuzzy math, I think there's enough extras in milk production alone to cover that $9,000. So my kind of bottom line is, this is something we need to think about, or if we're talking to producers that are really having a conundrum, and maybe they're one of those producers that are thinking about going to a anaerobic digester and know that sand's an issue, and they know to make that cash flow somehow, they need to switch from sand bedding to manure solids, and they really got a lot of concerns about this thing. Maybe this is one of the ways to lessen the concern about going to manure solids, is to do some drying in between, and it's not that costly. The key thing, it's not costing. It costs money, but it's not. There's a lot of other upside benefits to that. So bottom line is, if their bedding with manure solids has a high somatic cell count, it is clear that drying manure solids will increase profitability, save animals, and improve herd health. And this farmer will swear by that. And I'll have a slide of that. He'll share his information. So if you would run into a producer that's doing manure solids, which is fine, and they're bedding, which is fine, and they have 150,000 BT, 150,000 somatic cell count for whatever reason their operation, yeah, maybe this is not something they want to think about. But if they are fighting or having high somatic cell count and kind of at wit's end of how to get that number down, this might be an opportunity to reduce that number. So with that, on the questions, I'll show you the next page here. My contact, Snooks or Snoops, I have the wrong acronym. It's hard to say. You can call these guys, Joel and Paul. They will talk to the producer straight up if you want, or they'll talk to you. And Reed Hoover, he was willing to share his phone number and stuff. Give him a call straight up, or have maybe if you're a farmer is interested, just have the farmer to farmer discussion. Keep us out of the middle, and say, hey, here's a farmer that's doing this. Give him a call and check into it. But I think it's another an opportunity for making manure solids bedding a better option than using green manure solids or having to go through the entire composting process like you would through a digester. And with that, Tim, I'm going to try to get you back on schedule, believe it or not. Well, maybe not, but anyway, we'll try.
You might have cost us 5 minutes. That's okay, Pete. All very good. Thank you very much. We did have one question come in so far. Did you do any bacteria counts of green versus dried? Or did
No,
Okay.
no, and that was not, and there's no question that the bacteria count will be down because you went through the heating process. Sort of like when you go through an anaerobic digester, you heat everything up, you're going to kill the pathogens and all that kind of good stuff. But here's a quick method of doing without having composting it for 26 days or spending on his farm, $1.7 million for a digester and going through that whole process. So no, I did not.
And two quick questions, Pete. You probably said it, but how long has he been running this?
Since 2015.
Okay.
So I think that's really a testament to this is not we just put it in last year we think is the greatest thing since sliced bread. It's been going on since 2015. So, it's good equipment, stainless steel, all the parts are running, nothing's wearing out. And there's maintenance, just like I had 3% maintenance. And there are things in bearings and maybe the motor and belts and a couple things like that. But there's moving parts just like any other farm. But got the right locations, under roof. No extra cost. They were bedding every day, or they're bedding the same sequence. So, the cost of the time to do the bedding and all that stuff is the same. So, a lot of benefits, and I don't see no negatives here.
And finally, do you know, have any other roasters been sold and implemented at other farms?
That is $1 million question. I did find out, and like I said, they had a couple they put out on some farms for the litter operations. They were running, but then at the end of the day, it turned out that they had the fire in one issue, which isn't good. But the other thing was the integrator didn't help the farmer with the integrator. So the farmer said, "Why am I doing this? I can make more money, but the integrator's not going to reward me for it. So why am I doing it?" And we had one other farm in central PA. I know the farm. They had the roaster there, but they had a digester and everything else, so they did not do it. So that's kind of an interesting question. So I'm hoping that this little presentation here will maybe stir the pot on you folks out there in the field. And if you do run across farmers that are using manure solids as bedding and have some issues with somatic cell count, hey, this is another something in the toolkit. It's not something we do, but certainly we want to help our producers out stay in business.
Thanks a lot, Pete. Another tool for the toolbox. Appreciate that. Thank you very much for sharing.
Yep.
All right. Well, with that, I think we are going to transition. So our next presentation is going to come from another name many in Pennsylvania will recognize, John Tyson. And John, for those that don't know, is a regional extension ag engineer with Penn State Extension. And he serves as a technical expert in many areas related to ag, especially dairy housing, cow comfort, farm layout, farmstead layout, feed storage, manure handling, and ag ventilation, which is the topic that he's going to cover here today. And he does spend time at events like this doing education, but he also works individually with producers if needed or if that would be helpful. So, John, thanks for sharing today. And if you want to kick things off with your roofed HOA ventilation talk, that'd be great. And it looks like we're seeing the presenter side. So if you just want to change the display settings.
Yep. How's
Perfect.
that one?
Looks great. Hey,
working?
Thanks a lot.
All right. I'll go ahead and take off here. Do have to give you a warning that I'm not a vet. This is required by Penn State Extension. I'm an engineer, not a vet. So any veterinarian advice that I accidentally give, check with your vet. So roofed housing or roofed high use areas, ventilation of those is a kind of a subject that I brought to Tim's attention that I wanted to talk a little bit about. And I guess, whoops, going the wrong way. Go this way. One of the things I think, at least this is my simple understanding as an extension engineer, I won't try to put a definition on one of NRCS's projects, but I think the major goal of heavy use areas is to protect the environment. We're trying to minimize and contain that runoff. And at first blush, it can seem pretty simple and straightforward, but sometimes I've been involved with some farms that maybe we didn't think about what the animal needs out of it. We're looking at the environmental side, the cost side, all those sides. But I guess as an extension ag engineer, I've always tried to take that stand that somebody has to represent the cow or the animal. I try to play that role. And really in what I work with, there's four basics of life. We need air, water, food, and shelter. That's really, it doesn't matter if you're a human, if you're a little bunny rabbit or a big dairy cow, those are the things that you need. But, the golden standard of shelter, and I'll use this as a beef illustration because I see a lot of these going into beef farms, small beef farms, a brood cow and her calf. This is really the gold standard for shelter. She doesn't need any, to tell you the truth. Maybe a little bit in the winter, a little bit keep her dry, but we're not looking for the ultimate shelter for these animals. And that would go for most all of our dairy animals, except maybe extremely small dairy calves that would need a little bit more shelter. So what are we looking for out of a animal housing basics is excellent air quality, keep animals dry, comfortable, resting area, give them good access to feed and water, because this is typically we're going to house them in times when they can't be on pasture, or there's really no pasture, there's nothing out there for them to eat, and provide some confident footing. That allows all the opportunities for these animals to become as productive as possible in whatever it is they're doing, either growth as a beef animal, carrying a calf to full potential, optimize milk production, whatever it is that animal has to get done. And I think that's where this excellent air quality comes in, and why I wanted to talk a little bit about ventilation. So this is my a little bit slide them on. I think it's a little bit in vain for us to think that we can improve on Mother Nature. So, what is it that we're trying to do? We're trying to mimic outside conditions inside the building and make life better and accomplish our goal of protecting the environment. But I think, we have to be careful to not think we're going to improve on Mother Nature. So a little bit of vet work. This comes from Dr. Wolfgang, a former vet here at Penn State, and then at the PDA. When we look at animal health, we have that lower line, which is the challenge, and we can either increase the resistance, and that comes through, good nutrition, vaccination, all those other programs we work with in management from a veterinary end of it, or we decrease that challenge. And I think that's where ventilation can come in, that we decrease the challenge on the animal. We decrease that bacteria load, and we decrease the challenges. And if we do both at the same time, we can actually get a really good bang, lower that challenge and increase resistance. So what are the challenges from an animal health standpoint? Well, there's fecal oral with certain animals, particularly young bovine. Of course, we always have animal-to-animal transmission, filth, air quality, airborne pathogens, drafts, and then extremes of weather, whether it be heat or cold. And this is where ventilation comes in. That's where ventilation is at its best. If we look specifically at pneumonia, we know that pneumonia is caused by a variety of bacteria and viruses, but some of the factors are high humidity, high levels of ammonia in the building, poor air quality, poor air movement. Then of course there's overcrowding, stress, and inadequate levels of colostrum in calves. But really, those first three are ventilation issues. The last three are more management issues. But ventilation, once again, plays a role in disease. So what is the ventilation process, or, somewhat used interchangeably as ventilation versus air exchange? I don't think they're quite universal in replacing each other, but air exchange is really what we're trying to do in ventilation. We're bringing in fresh air, mixing it with the pollutants that are in the building, and then exhausting that air in some manner. So we're exchanging fresh air for dirty air. Exchange is what we're after. Ventilation goes a little beyond that, but the exchange is really what I'm going to get after. There are really three different seasons we talk about. The first being the cold season, kind of where we are now, wintertime, minimal temperatures. And in Pennsylvania, that's not quite as extreme as it is if, some of you folks are in New York or Vermont. Farther north, we get into the Midwest where, temperatures are a lot lower. We have that warm season or hot season in the summertime where we're trying to control temperature. I should go back to the cold season where really what our ventilation or air exchange is trying to do is control moisture within the building. In the summer, we're controlling temperature or trying to maintain a better environment temperature wise. And really the challenging part of the year for many producers and many structures is that variable time, that spring and fall, where we get, one day it's 65 degrees, 2 days later it's 40 degrees. The nights vary back and forth from freezing to above freezing, below freezing, and we really are chasing back and forth between temperature control and moisture control and trying to adapt to both systems at the same time. When we talk about temperature, because that seems to be what defines our ventilation systems, is we got to remember that cattle are homotherms, which is no fancy term other than the fact that they maintain an internal body temperature, just like you and I. Cattle tend to have a temperature of around 100 to 101. That's their normal operating temperature, and they maintain that regardless of the environment within reason. So when we look at that, we define two things on that scale of temperature, an LCT and a UCT, which is a lower critical temperature and upper critical temperature. Below the lower critical temperature, they have to do something different. So between those two, we talk about a thermal neutral zone. That is where cattle can maintain their internal body temperature without doing anything extreme. Their body has evolved to handle that. Below that temperature, they're going to begin to shiver. They're going to begin to do things to keep themselves warm. Above that, they're going to have to do something to cool themselves off that is at the ends or edges of their physiological abilities. We define inside that a cool zone and a warm zone, and really thermal comfort zone falls in the middle. And this is sometimes where you hear terms like thermal comfort and thermal neutral being interchanged, and they're not the same. The thermal neutral zone is much larger. That's where her physiology says she can easily maintain her body temperature. The thermal comfort zone is where she would prefer to be, she or he, but they can go on either extreme. When we put things like feed intake over it, you'll see that feed intake is much higher at lower temperatures, because one of the things that an animal has to do is increase their calorie intake to create more body heat. As they get warmer, they're going to eat less. The difference between that maintenance, that yellow line I just drew in there, that's the maintenance line required to maintain that body temperature or maintain physiological function. The bigger we get between those two is where we can have production, whether it's beef production, egg production. This works for all animals, milk production, whatever. The larger we can get between those two, and that's kind of what defines that thermal comfort zone, is that's where he or she, depending on the animal, can maximize production. Beating around, not talking about ventilation, but I think it's important to define why we talk about ventilation and what an animal needs, particularly cattle. So when we look at these temperature zones, this would be the markers on that graph for a typical beef cow, a pregnant brood cow. This time of year, she's carrying calf. She's in another month or so, we're going to hit calving season. So she's heavy with calf. Lower critical temperature is about 5 degrees Celsius, 5 degrees Fahrenheit, maybe even a little lower than that, which doesn't happen very often here in Pennsylvania. As you get into you get into New England, we're going to push that down some, but she can handle a little lower than 5 by increasing management skills, or by the producer increasing management by increasing calorie intake. You notice she would like to be between 40 and 68, 41 and 68. So they'd like to be at 50, but that isn't going to happen. They have an upper critical temperature of about 82. So summer heat can affect these animals. Different animals affect differently. If we, whoops, went the wrong way again. if we look at a, now this is giving the temperatures of a steer. So this is a yearling steer, it's on a feedlot, high energy diet. You can see that they're the lower critical temperature because of the amount of calories that animal's taking in is minus 31. Minus 31 really doesn't happen in Pennsylvania. I would argue it probably doesn't happen an awful lot in New York, or maybe for a few days as we go further north. We don't get the environment of days and days on end of minus 30, but a beef steer could survive that very easily. But you also notice that we've moved down the upper critical temperature. Now anything above 77 affects production. So that whole thing has shifted based on the animal. So we don't need to shelter them from cold. What do we need to shelter them from? Moisture, of course, snow and rain. If we keep that hair or hide dry, we're going to increase their ability to manage cold weather. Extreme winds, and I'm not talking that 1 or 2 mile an hour breeze that's kind of blowing all the time. It's the extreme winds, the 10, 15 mile an hour gusts that are going to steal some heat off those animals. That's the extreme winds we got to protect them from. And of course, in the summer, we're going to protect them from the sun, take away that solar heat load. So the goal of the ventilation is to provide fresh air exchange, control moisture, gases, and pollutants. Try to do it uniformly throughout the animal space. We don't want to underventilate. We can't run on averages where we have one end of the barn that's overventilated and the other end underventilated, and on average we're good. We have to do it across the whole building, and then protect from weather extremes, and mix throughout. The goal from a humidity standpoint, at least coming from Midwest Plant Service, is the ventilation is to try to maintain a room relative humidity between 40 and 60%. That's felt to be where we can maintain the best animal health. Humidity higher than that can cause condensation, can add to airborne diseases, and other lower humidities may increase our dust levels. So, that's kind of that happy medium of 40 to 60. Over that is detrimental, and more bacteria is found if we push it beyond that 40 to 60 range. So what is the heat production? Once again, I went back to a 1,300 pound brood cow on a maintenance diet. That column labeled SHL is sensible heat loss in BTUs per hour. So at -5, that sensible heat is the heat you can feel coming off the animal. That's why it's called sensible heat. You touch a warm body, it's warm. You touch a cow, even though it's -5, she's warm and she can give you that heat. That's the heat she's trying to give off to warm up the environment around her. As you see, as the temperature goes up, that is going to go down, because as the environmental temperature gets closer to her body temperature, laws of thermodynamics, the heat transfer slows down. But what does that mean in simplistic terms? So I threw this into a heating of your house. If you had a 2,000 square foot house, on average, we need about 3.5 tons of heating to heat that house. A ton is 12,000 BTUs. So do the math, and you'll find out that at -5, you could heat a house by putting 25 brood cows in the basement. You wouldn't need an expensive oil furnace or LP gas or to cut firewood. Just shove 25 cows into your basement. Your 2,000 square foot home will stay heated throughout the winter. The downside to that is that while they're producing all that heat, they're also pumping out an inordinate amount of moisture to the tune of about 1.3 pounds per hour. Pints a pound the world round. So 1.3 pounds is about 1.3 pints. Do the math again on those 25 cows, and your basement will be adding 4 gallons of water per hour. So over 70 gallons of water every day is being dumped into your basement. And if you didn't remove that water, what's going to happen to the structure, to the air quality of that building? So that moisture needs removed, both from a health standpoint of the animal and building health. Ventilation simply is using some simple air properties that, cold air this time of year, it's cool outside, higher relative humidity. We have dense our air is considered to be dense. You have this little box that's, 3/4 full of water, say, relative humidity of 75%. If I add some heat to that, sensible heat, what happens? Air naturally expands. The volume of that air increases, but the amount of water does not change. So my relative humidity, and this is an extreme example, I've went from 75% full to now I'm, 10% full. As that air expands, as it gets warmer, it becomes lighter and it becomes able to absorb more air. So what we do is we bring that cold air in from outside, we add the animal heat that we already are that's being produced. We mix that around, that now warmer air that can hold more moisture, sucks up the extra moisture in the building and kicks it on out. What are our alternatives, natural, mechanical, or combinations? I'm going to focus on natural. I've got to keep it moving here, but natural ventilation is powered by wind. And as wind blows against the leeward side of a building or the windward side of the building and goes up over the ridge, if it happens to be a ridge or any shape thereof, we always get a positive pressure created on the windward side, a negative pressure on the leeward side, and with proper design of a ridge, we get a negative pressure at the ridge opening. Those pressure differences is what drives natural ventilation, particularly in the winter where we have small openings. It's the pressure difference being driven by this. And air moves from high pressure to low pressure. So it's going to leave the barn. It's trying to find that low pressure, which now is created at the ridge and the leeward side. In the summertime, we remove the wall completely, and now it's driven mostly just simply by wind speed and size of opening that's driving that air through the building. One other driver of natural ventilation is heat. And as the air temperature increases, it becomes more buoyant. So with these animals inside this building, we're creating a chimney effect, much like you would have draft on a fireplace. Usually we're trying to stay within 5, maybe at the most 10 degrees difference from inside to outside. And if we do that, we can drive this thermal effect in the winter. I'm an engineer, so we're all engineers here. I think a lot of us are anyway. Got to show some equations, and there are some empirical equations. The important thing is to remember to look at these as what drives that Q, what drives that ventilation rate. And here it's the area of the inlet and the effectiveness or the orientation of the building. This is the equation for wind-driven natural ventilation. Here's the thermal buoyancy equation. What drives it is that small temperature difference. Then once again, area and distances between it. But we have to have a small we have to get some type of temperature difference to drive thermal buoyancy. In larger animals like beef, or more concentrated, like even if you have sheep, many sheep inside of a building, there's enough of thermal heat in there to drive these systems. Smaller animals like calves that don't have a lot of extra heat have some issues making thermal buoyancy work. Looking at that building characteristics, exposure, orientation, separation, and then we'll look at some features. What we're looking for from an exposure and orientation, at least from a ventilation perspective, is trying to get the building perpendicular to prevailing winds. That way the building sees more of the wind sees more of the building, whichever way you want to put it. And it moves across the building and it effectively creates this positive and negative pressures on the building as it goes up over that foil. Much like lift on a plane, we talked about lift is the one big problem, one of the things to be considered in all buildings for structure. That's what that lift is what drives this ventilation system from a wind standpoint. If we look around here in Harrisburg, you mostly see a westerly wind here in Harrisburg, in both summer and winter. Throughout Pennsylvania tends to be mostly a westerly prevailing wind. You get into the southwest corners or the northwest, you see a little bit more of a southwest turn to it. And you look across the United States, the prevailing winds are very much different as we move around the country. In Iowa, they have a southerly wind. Here in Pennsylvania, it's kind of southwesterly to westerly. You know, there are places where it comes out of the east. It's very regional, and you have to identify that to understand what the wind's going to do to your ventilation. As I said, ideally we'd like to be, perpendicular to it. That's from a sidewall orientation, ventilation the best. But we get some sun intrusion. If we go east and west, we get less sun intrusion, but perhaps not the best ventilation. In Pennsylvania, I see an awful lot of sort of sideways, northeast to southwest orientations. Gives a little bit of sunlight and at least comparable ventilation options. Open front buildings, something else to talk about. We typically turn that open front away from the prevailing wind. So once again, you got to know the site location you're on. If you're going to have one wall that's wide open, we want to turn that away from the winter winds to block and get some shade in the summer, along with blocking the winter winds. Sun intrusion, if we're after trying to get sun in, this morning, I think Jennifer talked about, orientation for solar panels. This could play into it too, as to which way you want to orient the building. Talk about monoslopes. We've always said that monoslopes had an advantage in the winter of getting sun in, but then trying to exclude it in the summer if there's animals in there year round. Gable roofs, not as much solar makes it in because of a lower roof profile. But, here we have a north-south orientation of the building. You got some sun in the winter, less sun in the summer. Just another thing to play into the equation. But to be honest with you, what I see wins 99% of the time, in Pennsylvania at least, is topography. Which way can the guy driving the bulldozer make a flat spot for the least amount of money? That tends to win our orientation, and we got to work with it. So if we have to work with it, what are some other things that get into this effectiveness of wind velocity or ventilation? And you'll see that down here at the bottom, this A is an exposure factor that we give it. And 0.4 or 0.14 to 0.4, depending on whether it's smooth terrain or rough terrain with tall trees and other buildings. And that is a exponent for the equation above. And what happens is if we leave the building's height the same at 14 feet and we change the exposure from smooth terrain at a 0.2 to rough terrain at a 0.4, we've reduced the ventilation or reduced the velocity by a little over 25%, a little over a quarter. The air velocity directly goes into ventilation, meaning we've decreased ventilation by about 25% by simply picking a site and an orientation that puts us up against having rough terrain on the windward side of the building, rather than finding an open area with pastures or smooth terrain upstream or on the windward side. So site selection, we're looking for high ground and looking for an open area. I was told many years ago by a fellow educator that he had figured out the secret to being an ag engineer and orienting siting buildings. He said you start where you're standing and you walk uphill, and as soon as you take one step downhill, you back up and drive in a stake and tell the farmer that's where to build. And he was pretty much right. We're always looking for high ground to catch as much wind as possible, and separation of 50 to 75 feet from other buildings, silos, because these other buildings can affect downwind airflow anywhere from 5 to 10 times their height. So another building that's 10 feet high can have a wind shadow anywhere from 50 to 100 feet downwind of its leeward side. What if we look at the building features? This is where we get a little bit closer to talking about some design values. The ridge opening, the ridge vent, and the sidewall opening. That ridge vent, as I think Brent mentioned, we talk about that here at Penn State as a minimum of 12 inches of building up to 40 feet. And then for every 10 foot over 40 foot, we add at least 2 to 3 inches per 10 foot. That difference between 2 and 3 inches would be, are these young animals? Younger animals, we would add another 2. If they're older animals, big brood cows, dry cows on a dairy, producing a lot of heat, we would probably favor towards the 3. If they're young heifers, 6, 8 months old on a dairy farm, I would tend towards an additional 2 inches for every 10 foot of width. And then you have to have equal openings on both side walls. If this is in fact a closed building, as the picture on the right shows, there has to be an eave opening on both sides to balance out that ridge. What can be done to protect the ridge if we want to try to exclude and don't want a wide open ridge? We want to try to protect whether it's a timber structure or maybe there's animal housing and bedding directly under that. We can use overshots are probably the most often used, at least here in the Northeast that I see, occasionally an overshot with an upstand, but these overshots usually can be built right into the truss. Whether it's a wood or steel truss, it can be kind of manufactured into it. Doesn't take a lot of work on site to get it done. One other option that can be used, and usually I don't see it much here in Pennsylvania in cold housing, but some in northern climates, northern New York, New England, up into Canada, we'll see some insulated buildings using chimney vents. The rule of thumb there is to try to provide at least a half a foot, preferably closer to 1 square foot per 100 of floor space. So it's a 0.5% to 1% exchange, and then try to not space them more than about 40 feet apart. And it does very much the same thing. It provides somewhere for the wind to blow across, create that updraft that is going to help in wintertime ventilation. Then the thermal buoyancy, as hot air rises and takes that moisture along, it needs somewhere to go out. So whether it's an open ridge or a chimney, we need a hole in the top of the building. Sidewall design, typically I don't see anything less than 14 feet, maybe occasionally 12 on smaller animals, but 14 feet. A lot of it has to revolve around clearance of equipment. If we're going to get a big skid steer, a tractor with a loader on, what kind of equipment are we going to get through this building? So it's clearance there. And adjustable. If it's fall to spring housing, or if these are, use the example of brood cows that are going to be put in at early or late fall after the grass is done growing, they're going to go back out to pasture in April. And we're really not housing during hot periods of the year, we probably can get by with 40 to 50% of the wall being able to open for those variable times like we had a few warm days here a couple of days ago. If it's year-round housing, I think we have to be able to open up at least 75% or more of that wall for the summertime. Another rule of thumb that kind of just became adapted, there's not a lot of advanced science behind it, is a sidewall height or an eave extension of about a third of the sidewall height. So, about 4 feet or so, basically trying to get moisture water away. That helps protect if those curtains are open or the sidewalls are open, protects a little bit from rain or snow blowing in. It also protects the foundation, whether it's a concrete foundation or posts in the ground. Getting water away from that structure is going to increase the longevity of that building. So having an eave extension to get water away from the building will do an awful lot for building health. Mild weather, we just simply open and close those curtains, and I prefer curtains. It can be done automatically, but mostly is manual. And while I say I prefer curtains, because of their ease of operation, the maximum ability I can have to open sidewalls, it can be done with doors. This is an illustration of a building where the producer really didn't like the option of curtains, wanted more of a solid look. Granted, we probably didn't quite get to that 40% level, but this is just for brood cows in the winter, have the ability to open these open doors up and open up at least a large percentage of the building to get air through. The overwhelming thing I'm trying to get across is that solid walls don't work. They don't, beef animals, dairy animals, sheep, goats don't need the level of protection that we think they do sometimes. We need to get more air in these buildings, have some flexibility to get air in, get good ventilation, and increase herd health. This is a farm that had never had health issues with animals. Built a heavy use area, wound up having a lot of sickness, and I think even lost one or two animals the first winter they were in it due to health pneumonia issues in brood cows, and was just about disgusted at everything because he had never had a sick animal before when they were just roaming the countryside, thought he was doing nice things by building this building, and created an issue. And its lack of ventilation is what really brought this on. So, what if there's animals in there in the summer? I think then you have to at least bring the point up with the producer that they may need to do something for heat abatement. They're going to have animals, in a little denser, a little more dense environment than they would if they were scattered out on a green pasture. So we're going to have to provide some heat abatement, i.e., circulation fans. And I know this is a dairy illustration of dairy cattle on a bedded pack, but it proves the point of circulation fans in the summertime. You can maximize the sidewall opening, but we don't control the wind blowing. So we have to supplement that air movement in the summertime within the building. So just to try to summarize, to keep us moving along, natural ventilation doesn't just happen. It takes planning of eave openings and ridge openings for winter ventilation and summer ventilation for that matter. The summer, we need to maximize those sidewall openings and end wall openings. You need to size the inlet correctly and have orientation and sighting, at least in the discussion when you start off with the design, as to are there better ways to orient the building or ways to stay away from? Are there places that the building would perform better from an animal health and productivity standpoint? Um, you know, you only have the chance to orient the building and site the building once in its lifetime. We can make a lot of modifications on, removing sidewalls, adding fans, adding ridge openings, but it's always going to be the same place and it's always going to be oriented the same way. And we try to limit the restrictions to that opening. Are there other buildings in the way that could be removed? Are they buildings that no longer serve a function? Are there abandoned silos that could be taken down? Trees that could be, cleared to make some opening, get better airflow in? From an overall ventilation summary, I hope I've tried to drive home the point that at least in the wintertime, moisture is the enemy in an animal shelter to both the health of the animal and the health and longevity of the building. Air exchange needs to be high enough to control that moisture in cold weather. With larger animals, we can use that extra heat they're producing to warm that air up, create a larger sponge, soak up more moisture, and kick it out of the building. So we can use that extra heat they're already producing to our advantage. In the wintertime, we're usually looking for a temperature difference of no more than 10 degrees. I'd prefer it to be closer to 5, but 5 to 10 degrees. If we go to a larger difference than that in cold housing, meaning non-insulated, is usually the first indicator of throwing up a red flag that it's time to increase ventilation, figure out what's going on, because if we're keeping the building too much warmer than outside, we're going to create health issues. And I always like to tell people that of all the vets I've ever talked to, I've never known a vet that's done a necropsy on an animal and declared that animal died from drowning in fresh air. Fresh air will not kill animals. It does them good. We need to have some way to monitor this. It can be as simple as a thermometer. The producer, and this doesn't fall on the designer, but it falls on the producer, has got to manage and monitor it for moisture level, gases, pollutants, temperature, all those fluctuations. That's all management. And that's where I say that good managers can outdo a poor facility, but poor management can kill the best engineering in the world. So the producer needs to know what they're getting themselves into, and maybe needs a few pointers on how to manage this facility, and it would help a lot. So with that, I'm going to say I'm done talking about ventilation. I don't know where we're at for time, but I like this quote I found that man cannot change the direction of the wind, but he can adjust the sails. So that means we can move the curtains. We just can't figure out where the wind's coming from.
Hey, thanks a lot, John. Greatly appreciate that. I think some of us have a tendency to laser in on water quality benefits, but we need to be providing systems that work well for the producer and for the animal, probably more important even for the animal. Also took me back to some Dr. Buffington classes at Penn State. I remember him always preaching that I think he used to say we're tea kettles, putting off heat and moisture constantly. So good thoughts there. We do have a couple of questions in the chat for you, John. The first question, would an end wall also need a ventilation opening if we have adequate sidewall openings?
Typically, it depends. In winter or for winter or spring or fall, the cooler climate, we typically don't worry about end walls as much. If we're trying to maximize ventilation, say in the summer, and when I'm dealing with dairy housing and, they're middle of July, they still got a pack full of cows. Yes, end walls are very important. I tell producers that if it's not structurally important in holding the roof up, it should disappear in the summer. The winter is less important because we don't need as much opening. So I guess I'm not answering the question. Depend on what time of the year you're trying to balance the ventilation system for.
Okay. Next question. As you noted, sometimes terrain dictates what we do, and sometimes terrain dictates higher support walls. Are higher walls a detriment to ventilation? Can we make up for this by having curtains on top of those higher walls?
You can make up for it to a certain extent. The higher the wall, it's going to create a dead spot below that wall. So 4-foot high wall, typically we don't have a lot of issue with. If we had to go to a 6 or 7-foot high wall, there could be, that the air's not going to reach right below that wall. And the curtain above it's going to help. And I think if we ventilate the entirety of the barn, will be okay. But I'd still want to have, if I had a 6-foot high wall, I might want to bump maybe I want a 16-foot high building so I can get a 10-foot curtain above that or something. But it's a detriment. The higher that concrete wall, because the animal's living in the lower 4 feet. And maybe it's not going to be as bad in cold environment as it would be in the summer, when now there is absolutely no way to get fresh air in the middle of July to that animal without placing fans in there to blow it directly down onto them. So it's a detriment, but I think it can be overcome.
Okay.
Now, one of my biggest reasons for not liking those massive high back walls is typically that means I built the building on the downhill slope of a hill, and that's decreasing my ability to get a breeze. I'm building a bank barn where the bank is protecting my building from getting air. I guess that's where I see a bigger detriment. It's not specifically in the support wall, it's in the fact that now I've built the building in a hole.
Yeah, thanks, John. Now, do you have fact sheets or resources that can be provided to producers who are making decisions about how they want their structures planned?
Yeah, I mean, we have, there are some, on the Penn State Ag Engineering page, there are some idea plans. They're mostly around dairy, but many of the bedded pack heifer barns would be equally usable to, beef housing. If you want to see any of those, let me know and I can send you the link. They're all on the web, or if you simply get on the Google and search for Penn State dairy idea plans, you'll find them.
Very good. Yeah, maybe after your presentation, if you don't mind,
I'll shoot you that link.
That'd be awesome. Another question: should the overshot ridge vent be open away from the prevailing wind?
Yes, it should be. I kind of forgot that. Jennifer remembers back to Harvey's class too.
And very good. Your ridge opening guidance that you have, what assumptions are made with that? Is that assuming ideal orientation? And if you don't have quite ideal orientation, how does that change your ridge vent opening recommendations?
No, I mean, it really wouldn't change it much. I mean, the idea of the 2 to 3 inch or the 12 inches, ideal orientation is we assume we're within 45 degrees of perpendicular. And if we actually get to truly parallel, the ridge really doesn't do much anymore. So it wouldn't matter how big you made the ridge. If the wind is truly blowing parallel, it doesn't create much of a pressure difference, because now it's blowing, you're not getting that uplift coming across the ridge. So I don't think you would change it based on orientation, but we try to get orientation within 45 degrees of perpendicular. And that's why in Pennsylvania, both north and south and northeast, southwest tend to work.
All right. I think that concludes the questions. We really appreciate it, John. Thank you very much. And you make us a couple of calls after this talk as we start to work with some producers on orientation moving forward.
Good enough.
All right. Hey, thanks a lot, John. Much appreciated. Okay, we're going to continue on with our agenda. Our next presentation is going to come from the Susquehanna River Basin Commission, and we've got two presenters from the SRBC. Todd Eady is going to kick off the presentation, and Todd is the manager of the project review program at the Susquehanna River Basin Commission. And in this capacity, he is responsible for overseeing application processing and approvals for withdrawals, consumptive use, and diversions. And then after Todd, we're going to hear from John Ballet, who's going to cover the second half of our presentation. And he is the manager of the Planning and Orientations program at the SRBC. And in this capacity, he is responsible for overseeing a variety of water resource planning and management efforts, including water availability studies, consumptive use mitigation, flood risk management, drought monitoring and operations, and in-stream flow protection. So with that, I'm going to kick it over to you, Todd and John. Thank you very much.
Thanks, Tim. This is Todd Eady. Can you see? I tried to share.
Yes.
You can see the
yes.
Introduction slide. Okay, great. Thanks a lot. We really appreciate the opportunity to present to you today. What I'm going to just start out with is just a brief overview of the commission, and then provide some information on our regulatory program and a little bit of what we do in the regulatory program. And then, like you said, I'm going to hand it off to John Balai, and then he'll provide some information on some of the activities that his program does in planning and operations. And then I'll hand that off, and I guess we'll hold any questions till the end, and then we can cover questions at the end. Let's see if I can advance the slide here. So are you seeing the second slide there? I guess.
Yep.
So the commission is a federal interstate compact commission. We have 4 members of the commission. It's the federal government, New York, Pennsylvania, and Maryland. So I like to say I have 4 bosses that I have to report to. The compact that establishes the commission really established some broad water resource management authority. It included aspects of water resource planning and water quality coordination. Our area of operations and authority is anywhere within the basin. And so it crosses state lines, and really part of why we were established is to manage this resource that crosses those state lines and work cooperatively with the other states and the federal government. So here's just a slide on some of the programs within the commission. John Balai is going to be presenting here with planning and operations. We have monitoring and protection. They do a lot of the water quality monitoring and coordination with the states. There's compliance enforcement, which is the other half of the regulatory program. I manage the project review program, which many agencies would call it the permitting section. We have information technology, and then legal and policy. A little bit about what we regulate and our thresholds. We regulate withdrawals of groundwater and surface water. consumptive use of water, diversions of water into or out of the basin. We have a couple general permits that we've established for some very targeted project types that can be well managed under a general permit. And then we have a lot of natural gas activity. I'm sure you've all heard about that. But the withdrawal regulatory threshold is 100,000 gallons per day on a 30-day consecutive rolling day average. So really, it's actually a fairly significant, significantly high threshold. You know, it's basically 30 or 3 million gallons of water withdrawn in a 30-day consecutive period. It's triggered on that 30-day consecutive rolling average. So if you pull more than 100,000 gallons in one day, but then the next couple of days you're pulling less than that, the project may not trigger. Consumptive use is the lowest threshold, 20,000 gallons. Diversion, into basins any amount, and out of the basin, it's equivalent to the consumptive use threshold because that water is leaving the basin and is no longer available for use. There's some asterisks here next to consumptive use and diversion, and that's just really to remind me to mention that there are some exemptions established for agricultural projects, and I'll just cover those a little bit, mention real briefly in this slide. So the agricultural water use is defined in our regulation. Like I mentioned, surface water and groundwater is regulated for ag projects if it exceeds the 100,000 gallons per day, 30-day average threshold. Ag projects currently have an exemption from consumptive use requirements, mitigation requirements, and review requirements. The states have worked with the commission to address the consumptive use that occurs from agricultural projects. And so as established in the regulation, as long as that continues to be met by that cooperative effort with the states, then the ag is exempt from consumptive use regulations. There are certain exemptions for diversion of water by agricultural projects, and it mainly comes down to it is the parcel of land or the is it on the divide, the basin divide? Does it straddle the divide? And so if it were to be a withdrawal in the basin that is piped a long distance to lands and parcels that are not at all in the basin, then it may be subject to a diversion review and approval. And then the last thing I'll just mention, in the regulatory fee schedule that establishes our application fees and those kinds of things, currently agricultural water use projects are exempt from the fees set forth in the commission's fee schedule. So that's an additional exemption that agricultural projects have with the commission. So just a little bit about what we do when a project triggers review by the commission. There's certain requirements with the application. All applications require public notice depending on the type of project they are. There's agency coordination that the commission staff complete on review of the projects and the water use. And really the technical review of the applications is driven by science and groundwater. There's a hydrogeologic evaluation process. Groundwater projects are really a two-step process. It requires that hydrogeologic evaluation, collection of data to be able to evaluate things like sustainability and potential for impact from the groundwater pumping. And then there's the application portion of the review for the groundwater project. Groundwater projects, the review and analysis of those projects takes a little bit longer. There's usually an aquifer test requirement portion of that hydrogeologic evaluation, so it can take 6 months to 2 years, I would say, for that, depending on how quickly the project moves on doing the aquifer testing and reporting. And then there's the groundwater application submittal and review that could take 6 to 12 months. One of the things I'll also mention is that the approvals that are issued by the commission, they call them dockets instead of permits. Those are approved at the commissioner level. So the technical staff at the commission here, we review those applications, complete all the coordination, prepare recommendations, and make those recommendations to the commissioners at a quarterly business meeting. And then the commissioners can vote to approve, modify, or deny projects. So that also impacts the speed at which projects can be reviewed and approved. Some of the other things we're looking at is sustainability for multiple uses, preservation of water quality, loss of fishery habitat, impacts on recreational use, and cumulative impacts. So we're not just evaluating that individual withdrawal or water use. We're looking at if it's a surface water withdrawal on a watershed, we're looking at all the other users in that watershed upstream. We do some downstream analysis to make sure that there aren't conflicts in water use and that there's actually enough water available for the multiple uses within that watershed. So and we're really trying to look to meet a balance of protection and while allowing economic development. Once a project's approved, there's some standard and special conditions. There's metering and reporting, and that helps us to keep an eye on the projects, make sure they're functioning and operating in the way that they were reviewed and approved. It also provides data that we can then use to evaluate, cumulative impacts in watersheds. And John's program does a lot of that work, looking at and compiling that information and providing a good analysis of those cumulative uses within the watersheds in the basin. There can be mitigation required for adverse impacts if it's identified that there would be any. We look at making sure they're meeting water conservation standards and best use practices. We focus a little bit on low flow protection when streams are low. The impacts to the aquatic communities can be quite significant depending on the size of the withdrawal. So there could be some conditions related to that, special monitoring. And I have here expiration. Just wanted a standard approval term is 15 years. And really what that allows the commission to do is take a look at these projects again, see if they're continuing to operate in the way that they were originally reviewed and approved. And then also have a checkup on the full cumulative use within the watershed and make sure things are being managed appropriately. So I think I'll just stop there, hand it off to John, and I look forward to any questions maybe at the end. So, all right, John, advance to your slide.
Great, thanks, Todd. Can you give me a thumbs up if I'm coming through audio-wise?
Yeah,
Great.
It's a little choppy, but it's not too bad.
Great, thank you. And thanks again, Tim, for the opportunity and the brief introduction in the beginning. I'm going to cover in brief a study that our program in planning and operations completed for our agency late last year that we think has some relevance to your all work with respect to agriculture and in a broader context, water resource management in the Susquehanna. Todd, if you wouldn't mind switching slides, I'll just say next when we're go. Thank you. So the goals of this study, and it was really teed up by some work we had done several years ago in developing a groundwater management plan for the Susquehanna, and in subsequent work in our agency's comprehensive plan. We really set out from a groundwater management perspective to try to identify areas of groundwater recharge in particular watersheds for their long-term preservation, protection, or restoration as a way to support water supply sources in the drainage. For this study, our aim was to try to identify those across the basin scale, and then with the ability to apply at a finer spatial scale, whether it be a county scale or a watershed scale for more local type applications. And the way we did that was in developing a GIS framework I'll explain in the subsequent slides. With that GIS framework and our ability to identify areas throughout the Susquehanna where groundwater recharge is expected to be greater or lesser, we can then begin to really focus on watersheds or regions of the Susquehanna we feel either just naturally because of geology, precipitation have are more water challenged, as well as ones where water resource development and in general just development has perhaps created water availability concerns. And then within those areas, by being able to delineate these aquifer recharge areas or groundwater recharge areas, we could better manage those for long-term sustainability, particularly for groundwater supply. Next slide, Todd. Thank you. So in GIS, we used this concept called multi-criteria decision analysis, and the graphic on the right shows it well in a conceptual manner. Basically, we're stacking a set of GIS data layers, and basically we're standardizing them. We're applying weightings to the various data layers in GIS. And an example of some of those and are shown here: land cover, topography, soils, those sorts of things were the types of layers we looked at. And by applying weightings and going through numerous iterations of different combinations of variables and weightings, we're able to compute like a composite suitability score that allows us to look at areas of the Susquehanna that we feel are the best at recharging groundwater and ones we feel are least efficient at groundwater recharging groundwater. That composite index score is really kind of the bottom line product we produce there. So if you picture a layering of GIS data sets in raster format, and the pixels, I'll talk about scale in a minute, but the pixels for a particular layer are multiplied by a weighting we've assigned, and that produces that overall score that gives us some insight into recharge potential. Next slide, please, Todd. So some of the variables we use to do this and assess recharge potential are shown in the table to the right, but I wanted to explain for a moment some of the requirements we were faced with in trying to identify data sets permissible to use in this context. And one was to have coverage for our entire basin. And as you can imagine, that poses some challenges when you're crossing 3 state lines, to have a consistent data set that spans each of those 3 states and gives us watershed coverage. We also wanted to use data that was readily available in the public domain, didn't have proprietary conditions, didn't require detailed site investigations, basically desktop suitable open source data out there, and to a large degree was available on the POSDA website in Pennsylvania. And then third, that those data sets conform to a standard common denominator, if you will, spatial scale, 30 by 30 meters. So we felt like that was a can live with spatial scale to begin to look at these areas of recharge. So on the right, you can see the table of variables or factors, if you will, that we used in doing the study. This is obviously a short list that we produced from a longer list, the starting point, but you could see at a higher tier, we're talking about land cover. We drill down to geology, surface geology, and then structural geology. And then in the second tier factors, we drill in a little bit further and we get into things like impervious slope, soil, depth of soil, and then the density of drainage network, karst features, and faults. You could see the weightings applied to each of those, and those are critical to us producing that composite score for each raster pixel, and then that's summed for our area of interest, be it the watershed or the basin overall. Next slide, Todd. The end product in terms of the geospatial mapping coverage we were able to produce is shown in this slide. On the left, we're looking at recharge potential across the entire Susquehanna watershed. The blues are areas based on this approach that suggest are producing the highest recharge potential. And then the areas that are least efficient in terms of recharging groundwater are shown in the darker mahogany, if you will, or even burnt orange kind of colors. On the graphic on the right, we basically extract that highest 20% quantile of values for recharging, and we plot those in the Susquehanna. So basically, that's the best of the best in terms of recharge areas across the Susquehanna basin-wide. Next slide, please, Todd. So this basin coverage is great, but a lot of our work tends to get at a finer spatial scale, either at the watershed scale or project scale. And the beauty in the tool we've developed is the ability for us to adjust its application scale-wise. So we can look at things basin-wide and find the best recharge areas relative to the Susquehanna overall, or we can say, you know, we're interested in Conestoga watershed in Lancaster County, and we want to drill in and look at the best recharge areas in that particular watershed relative to what that watershed has to offer. So we can apply this tool in watersheds in the Susquehanna that we know to be challenging in terms of groundwater recharge potential, but still use the tool to identify the best recharge areas in even those more challenged groundwater recharge watersheds. And at this scale, we can begin to contemplate implementation of projects, whether attempts to preserve some of these features. We know we've done some work to demonstrate a lot of them exist on currently state-owned lands, whether they're DCNR state forest lands or Pennsylvania Game Commission state game lands. And we plan to do some outreach with them to help let them know the asset that exists on these publicly controlled lands and see if there are options to preserve it. We think there are opportunities to do that in agricultural lands as well. We've been working with Lancaster County Planning Commission and some of their agricultural protection activities to try to use these aquifer recharge areas as a screening criteria in selecting projects for ag preservation. We think there's a lot of potential applications in stormwater management context as well. That's kind of the middle bullet here. Ultimately, from our perspective, we want to use this data set to try to protect existing areas that are recharging groundwater supplies so that we can avoid potentially over allocating or overdeveloping groundwater resources in areas that are either water challenged or potentially stressed. Next slide, Todd, and then last slide. Thank you. One way we're intending to do this, in addition to just planning and collaboration and coordination context, is this funding mechanism we have available to us, termed our Consumptive Use Mitigation Grant Program. We are in year 3 of that grant program right now. Interestingly, applications for round 3 of this grant are due tomorrow at 4 p.m. But it is intended to be an annual grant offering at the tune of $4 to $6 million a year annually as a total. And this is kind of a shameless plug, but we think there are some opportunities here, not only to accomplish some of our goals for aquifer recharge or groundwater recharge protection, preservation, restoration, but also there may be some project concepts here that are of relevance to the agricultural community from a water supply standpoint that would be worth contemplating. This slide shows the 4 general categories of projects eligible for funding under the grant. The first one being water supply, and in the ag industry, it could be the development of additional water supply impoundments that could be relied upon, in particular during drought periods, to sustain operations and be more resilient from a water resource management standpoint. The second set of alternatives, the project operation alternatives, basically change the paradigm in terms of how a water user operates. Things like conjunctive use management, where maybe they're developing both surface water and groundwater sources to give them more flexibility in operating their system during droughts. Even development of drought contingency plans that lay out drought response actions to change operations to be more sustainable during drought periods. The third category is the one that deals all about water conservation. We've made good strides in doing water loss reduction projects in the public water supply sector, but we've also been seeing a good bit of irrigation operations coming in for upgrades to be more water efficient in that project category. And the last category of projects is broadest in scope. These may have relevance to agricultural operations. These are the category where we include the groundwater recharge or aquifer recharge type projects, but they include things like wetland and stream restoration, stormwater management, floodplain restoration, even riparian buffer establishment, dam removal. It's pretty broad. Anything environmental related that can make watershed or a system more sustainable during times of drought would be eligible. So we wanted to give a plug for the grant as a tie-in of another way we're trying to address our aquifer recharge area objectives, but also with the thought it could appeal, some projects could be appealing to the agricultural industry just in general. And with that, Todd, next slide is just for questions and to stop there.
All right. Thanks, John and Todd. We greatly appreciate that. I recognize that not everybody participating today is within the Susquehanna River basin, but we do feel that other neighboring water basins, river basins, have similar guidance criteria requirements, and thought this type of talk would be very applicable. We do have 2 questions in the chat right now. If water is pumped out of a stream for irrigation, is there any obligation to maintain a low flow even when that irrigation would be under the 100,000 per day average over the 30-day period? Must they maintain downstream flow? So this would be a small stream that we're irrigating out of, but could potentially dry up.
Yeah, I guess I'll, this is Todd Eby. I'll try to just provide some response. Requirements as far as the commission, no, we don't regulate. We would, if it's not above our threshold, we wouldn't regulate it. But there are things that come into play like riparian law, and so if you're eliminating the ability for a downstream riparian property owner to use water, then there's a water use conflict there that if pursued by the downstream property owner, that there could be significant issues there and legal issues. As far as impacts to the environment, organizations like Fish and Boat Commission, they have their own regulatory authorities, and if there's an impact to the downstream aquatic community, fish communities, things like that, if it resulted in a fish kill, there could be some issues there, and they could pursue some enforcement type actions. So that's just a couple of things that come to mind. I don't know if John had anything he wanted to add or.
No, I think that's good, Todd. I mean, like you said, ultimately, from our perspective, if they're under our regulatory threshold, we wouldn't be imposing any downstream flow requirement. But like you mentioned, certainly from a riparian law standpoint and other agencies with, in environmental harm avoidance emissions could get involved and it could be an issue.
Very good, thanks. And we certainly don't want to have negative environmental impacts in one area by trying to do a conservation project somewhere else. So very good there. Next question. If an existing agricultural facility is using more than that 100,000 gallon per day average over the 30-day period and has been historically, what would they need to do to be in compliance with SRBC regulations?
Yeah, they would contact us, and they would, if they were exceeding the threshold, then they could apply for approval for their withdrawal and use of water. The other thing I'll just mention here, and I didn't really talk about it in our presentation, is that there are a group of projects that we refer to as grandfathered. We went through started really doing a large grandfathering effort a couple years ago. We're getting kind of towards the end of that. We have had a number of agricultural operations register for grandfathering, and we've issued some grandfathering certificates for certain ag operations, and I believe there are a few more that need to be worked through the process as we wrap things up. But if their withdrawals were from surface water, were pre-1995, or from groundwater pre-1978, they could be grandfathered. It's really that would be kind of the first thing that would be checked to see if it's a grandfathered operation, and but otherwise, they could apply for approval and then work through that process and then get fully approved.
All right, thank you. And thanks for the link there, John. Appreciate that. I'll also note that I had a conversation like a week and a half ago with Matt Sandifer, who is the geologist for New York and Pennsylvania, and groundwater withdrawals is high on his radar, and ensuring that we don't have negative impacts to groundwater aquifers and how we ensure that is something that's really important to him. He's on paternity leave now, but he has some ideas moving forward. So even at rates much less than your 100,000 gallon per day average. So definitely something that's on NRCS's mind as well. So thanks a lot. Much appreciated. Thanks for sharing. And with that, we're going to transition into our last presentation, which comes from me. So I'm going to share my screen here. All right. So as you know, I'm Tim Peters, state engineer in Pennsylvania for NRCS, and wanted to give a couple of updates. Now I recognize that this part of the workshop is going to be pretty heavy Pennsylvania, but still thought it was worth sharing, and other states may be interested in hearing what's going on in Pennsylvania as well. And I hear some background noise, so I can't see the list now, but if folks wouldn't mind muting, that would be terrific. So what do I want to hit today in my presentation? Well, I want to talk about standards. What are we doing with a couple of standards? We have updated or in the process of updating a couple that were released by NHCP over a year ago, and specifically want to talk about 578 stream crossing and 635 vegetated treatment area. I want to mention something to look forward to, new standards that are out for release that we're going to be working on this year. So always we're interested in getting good feedback from staff and partners and the private sector and the general public as we update standards. And I'll mention the process there briefly and what practices we're going to be seeing later this year. And then I also wanted to talk about what are some program changes that Pennsylvania decided to do this year and how that would impact incentive payments. And then finally, just a quick update on staffing, where Pennsylvania's at staffing as it relates to engineering, and some fun stuff there. So I thought at this point in the workshop, a story might not be a bad idea. And you're probably wondering why I have the DMV shown here. Well, I just wanted to share a story about a friend, kind of a friend of mine back home when I was growing up, Jonathan. He was, when he turned 16, terrified to take the driver's test. He was an okay driver. You know, he had spent his time with a qualified driver, and he did fine, but he was terrified to take tests. He was terrified to take tests at school too. But everybody knew the route that the DMV required you to go through when you were taking your license test. And Jonathan, he practiced this course over and over. He knew it well, and he had memorized it, and just was very comfortable going to take the test. And that's how he prepared for it, by just doing it over and over. Well, a few days prior to the test, I don't know who it was, PennDOT or somebody added a stop sign along the course. And of course, Jonathan, you know, not thinking about it, just blew through that stop sign with the driver's license person sitting next to him. And of course, the driver's license person decided to fail him for his test. And so I like that story. I don't remember all the details, and I have some other Jonathan stories if anybody wants, maybe future trainings. But I like that story as it relates to standards. And I just want to say, don't be Jonathan when it comes to standards. Don't print off a standard from Photog and keep that for your entire 45-year career, and that's what you keep referencing. Keep going back to Photog. Why is that? Well, it's because when standards get updated, sometimes we do add stop signs to our practices. And so that's my segue into the standards and updating the standards. So the first one that I want to mention, a change to the 578 stream crossing standard, it's actually not a change, but maybe more change on my level, is that the NHCP release, the National Handbook of Conservation Practices, the national version that came out over a year ago, had wording in the standard that said signage had to be provided and guidance had to be provided to caution against use during dangerous flow levels, and that a gauge had to be installed in a location that is clearly visible to the user before traveling across the stream crossing. And I have to give a ton of credit to New York and Paula Bagley. They really paved the way for a variance here where we were able to make changes to this, but Paula and I and some other states mutually saw a few challenges to this wording. We saw that we believed this to be an expense to add this signage that wasn't really necessary. In our experience, stream crossings are applied in rural settings, and they're not used by a wide range of people. It's an exclusive use to that owner and that farm operator, and so adding signage was just unnecessary. And that hits my 2 bullets there. And then really finally, maintenance. We saw maintenance as being a potential issue too. Are these signs going to stay? If you have a gauge in the stream showing stream level, is that going to collect debris? Is that going to remain if there's a large storm event, or would that just be a negative impact to the stream crossing? So a couple of challenges, not huge challenges, but a couple of challenges that we saw with the national wording as it relates to Pennsylvania and New York. So really following Paula's lead, I was able to get a variance approved for Pennsylvania, just like New York was. And the variance was approved by Trent Snellings, who at the time was the acting national geologist. And I'll just make a note that our national geologist is now Susan Grover. But the new wording says evaluate all hazards posed by the crossing and address with appropriate safety measures. So when the crossing will be used by anyone other than the landowner or farm operator, provide signage and guidance to caution against use during dangerous flow levels. So they were able to approve this wording, and this is what you'll see in the 578 standard. That signage is only required when being used by groups of people or people other than the landowner or farm operator. One thing, the National Discipline Lead, they can ask for monitoring and reports back when a variance is approved. In this case, the NDL, National Discipline Lead, didn't ask for anything, so there's no expectation right now for me to report back to them annually, but they could ask for that down the road. So right now, I don't need to gather data from Pennsylvania NRCS staff as this variance is applied to stream crossings, but something that may come down the road. And I'll also make note here, if you jump to photog and you pull up 578 stream crossing, you're not going to see this wording right now. That's because I'm way behind on getting that into the photog system, and I will get that done soon. I've missed my deadline. It was due back in October, but just a full disclosure there that this stream crossing standard hasn't been released yet. It will be. It's ready to go. I just haven't clicked the button in the program quite yet. Okay, the next standard, which had two different needs for variances, and I'm going to hit them one at a time, but the next practice I want to talk about was the vegetated treatment area standard. And when that national standard came out, the national wording for that standard said, exclude all livestock, including grazing, from the vegetated treatment area. And this is a big change for Pennsylvania from the previous version of the standard. Pennsylvania uses the standard, well, just to take a step back, for people that aren't familiar, Pennsylvania uses the VTA standard often. We probably do 5 to 10 of these each year, and we would use the standard, the vegetated treatment area standard, to treat runoff with nutrient accumulations, maybe from a barnyard or milkhouse wastewater, and that water with the nutrient accumulations would be applied to a grassed area, the vegetated treatment area, and that area would be sized so that we're not hydraulically overloading it with water and that we're not overloading it with nutrients, and that the vegetation that is in that area would uptake the nutrients we're applying, and then that vegetation would have to be harvested. So just a quick summary of the VTA standard if you're not from Pennsylvania and aren't familiar with using the VTA standard. But the national wording for this came out and said that you had to exclude livestock altogether. And so historically in Pennsylvania, we would allow flash grazing, short stints of grazing to happen within that VTA as a way of harvesting the vegetation. Now, with a vegetated treatment area, vegetation must be harvested and removed so that nutrients don't continue to build up in that vegetated treatment area. Mechanical harvesting is fine. That's a good way of doing it, and as long as that vegetation gets removed. But some producers in Pennsylvania have historically successfully used flash grazing as a way of managing that vegetation. So the national wording here could change an approach that Pennsylvania was historically allowing, especially for smaller operations. It seemed to be something that could have been a way of preferred management. So the variance was approved by the National Discipline Lead, and that variance has wording that says exclude animals with the following exceptions. One, the first exception that must be met is that the operation is a small to medium-sized farm. It's not a CAFO. If you're not a CAFO, then this can be applied. Two, that grazing will fall under a prescribed grazing plan. That's Conservation Practice Standard 528. Within Pennsylvania, we promote 528 in a big way, and we expect to see that whenever there's grazing. So no big issue or surprise there. Three, that the vegetated treatment area site will have sufficient grade, soils, moisture conditions to support grazing and not have negative impacts. So we're just saying that it's going to have a condition that will support the grazing and that the grazing won't deteriorate that vegetated treatment area. And that's nothing new either. That's something that would have been in O&M plans anyways. And then finally, four, that nitrogen and phosphorus loading would not exceed the vegetation nutrient requirements. Vegetation must be harvested. So all things that we would already have been doing, we would make sure that N&P weren't being overloaded in that area. Pennsylvania has our Design Guide 5, which is a great tool put together by past state engineers and staff at NRCS, and really that's something that we rely on and feel very good about and feel that we are providing good designs and plans for producers, operators to implement vegetated treatment areas. So what did the NDL say? Well, in this case, the NDL didn't allow me to get away without reporting back. So that's really if there's one take-home point from my slides on the VTA standard so far, this is probably it. That I do need to have annual reporting of VTAs that are utilizing flash grazing moving forward. And as part of that, the NDL would really like to see soil tests taken. Now, soil test data, it will need to be provided, and that's something that should be noted and gathered as part of a 528 prescribed grazing plan, the monitoring plan that goes along with the prescribed grazing plan. So hopefully that's not an extra burden on producers to get those soil tests, but that is something that we would need to talk about. And if there's anybody that's currently working on a design where they're planning to use flash grazing as the way of managing vegetation, reach out and we can talk about how to put that in an O&M plan. And the NDL, the National Discipline Lead, over time, they will decide if the variance should remain or if the standard should be modified based on the reports that we're going to provide back annually. So that's something to keep in mind. If we want to keep the option of being able to flash graze, we'll need to provide data back that supports flash grazing is working. So just wanted to put that plug in that I'm going to need to gather data from Pennsylvania staff. Okay. So that was variance number 1 for the vegetated treatment area. Variance number 2 for the vegetated treatment area comes from the national wording in the standard that said limit vegetated treatment area slopes from 0.3 to 6%, which in Pennsylvania, we've been doing VTAs on slopes much steeper than 6%. And in fact, I tend to think that a manifold system on a 0.3% slope is probably not steep enough. So some things we didn't 100% love to see in the national standard there. What are the challenges? Well, Pennsylvania, we have topography. We have sites where it's going to be hard to find something less than 6% across Pennsylvania, especially in Western PA and parts of northern Pennsylvania. Challenge number 2, we have Design Guide 5, which will, it goes higher, it allows higher than that 6%, and we know we have good VTAs out there. And we historically, like I said, have allowed on steeper slopes. So all challenges. We've seen some issues in Pennsylvania with VTAs, but a lot of times those issues have been related to, pumps failing or solids not being screened out well or certain management or flouts not working. But I haven't really seen VTA failures as a result of the slope being too steep. In my experience, I have not seen that. So wanted to see about getting that changed, and we were able to do that. The variance number 2 wording, now the standard says limit slopes of VTAs from 1 to 12%. We need to follow Design Guide 5. We need to check that VTA twice per year. And if there's a 25-year storm event, that landowner needs to go out and check it as well, in addition to the twice per year. So a landowner may not know a 25-year storm events happened, but they probably would know if there's been a 5-inch storm event and over a day or two. So I think having an O&M plan that states that could be reasonable. And we need to limit VTAs, though the NDL did require this, to 6%. We can only do VTAs greater than 6% slopes on small to medium operations. Once again, something less than a CAFO. They didn't want to see that on large operations that are CAFOs. Another time where we're going to have some monitoring. So I'm going to need to do a data call at the end of the year to Pennsylvania staff asking if there are any VTAs that have been implemented on slopes larger than 6%, and we're going to need to get some data on how well that is operating. So I will need to provide feedback annually to the NDL, and once again, that's going to be, determine whether or not the variance stays or the variance goes. All right. So, transitioning to my next topic. NHCP, the National Handbook of Conservation Practice Standards, they release standards that are out for state review and then to be released by the states. They released that a couple months ago, and there are a lot of heavy hitters on the engineering side that are going to be reviewed. And they include the 7 that I have listed here. There's some big ones that we want to make sure that we get right in Pennsylvania. A lot of these are very frequently used and just big engineering practices. Now, there are some additional practices that are getting updates in addition to these, and that are engineering that we don't use quite so often, and we'll also be updating those. There are some ecological sciences practices that will be updated by the SRC, but I just wanted to highlight here that we do have some big engineering practices coming, and we'll appreciate comments back when they do go out. So for those that might be unaware of the process, though, nationally, these standards are developed and released through the NHCP, the National Handbook of Conservation Practices. States then can make them more state-specific once that release has happened. States are able to edit or change certain sections of that national version, but overall, it's just good to know that states, they can make the standard more conservative, but not less conservative. But typically, that's what's allowed. Once in Pennsylvania, once we have a version that we within the state feel is good or about ready, we then send that out for public comment through the state technical committee. So if you get those notices from the state technical committee, you will get this what we feel is the state version, and then we do love to get comments from the public to make the standards better or more applicable or just other ideas. And we always consider them. Sometimes we can't incorporate them, but we like to if we can and if it's appropriate. All right. Moving on. Shifting gears to some programs related items. This is a little bit of a change from last year related to CNMPs that are completed by TSPs and how they get contracted and the scenarios that are used to contract those. And this is probably good information for our TSPs and our NRCS staff. But last year, we used the CPA, the CPA 102, which was Comprehensive Nutrient Management Plan, and the DIA 101, the CNMP Design and Implementation Activity. And in Pennsylvania, if those two are contracted together, then we had a full CNMP completed by the TSP, the Technical Service Provider. Now in 2024, this year, this fiscal year, nationally, they made some changes to the documents. And I think one thing they did is they heard some feedback from TSPs and made some changes that are moving in a good direction. So the CPA 102 stayed the same, but the DIA, the Design and Implementation Activity 101, was revised. Now, as part of that DIA 101 last year, historically, if a waste storage facility was included in the plan, was being planned as part of that, a soils investigation, on-site soils investigation was required. This year, they pulled that requirement out of that DIA 101. So there is no longer a on-site soils investigation being required as part of that DIA 101. Nationally, they created the SEMA 226, which is titled Waste Facility Site Suitability and Feasibility Assessment. And that SEMA is it's a item that can be contracted, but it doesn't have to be done by a TSP, and I'll get into that a little bit. But this SEMA, the SEMA 226, is a soil data collection, investigation, and interpretation of the properties and characteristics to determine the appropriateness of a site for a planned storage facility. So that is no longer part of the DIA 101, and that's a separate item that can be contracted. Now, SEMAs, like I started to mention, are completed. They don't need to be completed by TSPs. They need to be completed by qualified individuals. And who is a qualified individual is defined in that SEMA document. So in this case, one would need to be either a PE, a certified professional soil scientist, an associate professional soil scientist, or someone with a bachelor's degree in soils with 8 years or more of relevant experience. I know that can be confusing. And if there are any questions about if someone is a qualified individual to do the SEMA, reach out to me and we can talk through that, and we can give some good guidance there. Additionally, last year in the DIA 101 was a requirement to evaluate existing waste storage facility components. This year, they pulled that requirement out of the DIA 101, and now that is in a new SEMA 227, the evaluation of existing waste storage facility components. So to be considered a qualified individual for this second SEMA, the evaluation of existing waste storage facility components, one would need to be an engineer, but they wouldn't need to be a TSP. They could be a registered TSP, but they wouldn't have to be to do the SEMAs. So you have to be a registered TSP to do the DIA and the CPA. You have to be a qualified individual to do a SEMA. And I know that's kind of confusing, but any questions, definitely reach out to me. Right. So for 2024, for NRCS staff, if we want to have a full CNMP contracted, we need to be contracting the CPA 102, the DIA 101. Those are definitely required. Additionally, if an existing storage is part of the site, and that's going to be part of what is being evaluated, then the SEMA 227 would need to be contracted as well. And that TSP could do all of those if they meet the qualified individual requirements for the 227, or the TSP could do the 101 and the 102, and the qualified individual could provide the SEMA 227 report. Additionally, it would be optional for the SEMA 226, the site suitability for waste storage facility, that soils investigation SEMA, to be contracted if a storage is planned. And we're saying that's optional, but we would encourage the SEMA 226 to be contracted if a TSP will be doing the design afterwards, if a private consultant will be doing the design afterwards, or if we're in a situation where some extra soils investigation would be warranted as part of the planning process. So maybe the site is known to have some sort of concern. Maybe there are coal seams we're not sure where they are, or I'm just trying to think of some example of where we would want more soils information as part of the CNP, the I&E, the planning stage. Well, if we had that situation, then planning and contracting that SEMA 226 during the planning stage would be appropriate. So I wouldn't be surprised to see these documents continue to evolve and change. I'm happy that National recognized that there are areas that can be improved, and I think we're getting to a good spot, but I also think there's still quite a bit of confusion with how the 102, 101, and 227 and maybe 226 all fit together to make a CNMP. But I do think nationally we're moving in a good direction there. Okay. Moving to something more Pennsylvania specific here. So one change we made, or the program staff made in Pennsylvania, was we increased the amount we can pay, the maximum we'll pay square footage wise for a heavy use area under CPS 561 to 100 square feet per animal unit. Previously, before this year, we were able to pay up to 65 square feet per animal unit, but for fiscal year 24, they have increased it to 100 square feet. And that's a significant change. That's a big change. Feedback that had been received by program staff was that, hey, a lot of times during an I&E, we're recommending a heavy use area size that is larger than 65 square feet. So program staff and our state con decided to make that change to go up to 100. Now, I will say the question has come up several times. Do we still need to use Exhibit 5 for recommending heavy use area sizes? And in Pennsylvania, for those that aren't from Pennsylvania, we have Exhibit 5, which is found on PHOTOG, and that helps step planners, engineers through sizing a heavy use area based on the animal type, the size, how they're going to be feeding, other ways that heavy use area is going to be managed, all being incorporated into a recommended size. Well, the answer is yes, we should still be giving the landowner a recommended size. That landowner should know what we are recommending for that animal group based on that Exhibit 5. And that size, along with the 100 square foot max, should be discussed with the landowner. Now, we're finding that a lot of times Pennsylvania engineers, when we're sizing these, are recommending sizes that are smaller than 100 square feet. So in those situations, the landowner should decide if they want to contract for the recommended amount based on what we've come up with using Exhibit 5, or if they would like to contract for the 100 square feet just to have a cushion or for some extra space for their animals. That 100 square feet is based on their current animal numbers. So if they'd like, they can go to that 100 square feet. If they want to go smaller based on the recommended size, then they could contract that amount as an alternative. Or if a landowner, or there could be times where we recommend larger than 100 square feet, and in those cases, we would be limited to a contract of 100 square feet. So trying to answer some questions that have come up related to that change. Okay, moving on. Some new scenarios. So we had some feedback, and this, I in some ways wish I wasn't following John Tyson's presentation as I talk about these new scenarios. So use these scenarios with caution and have good discussions about ventilation with producers. But if there's a need to have a 313, which is often alongside a heavy use area, there was feedback that we could use a scenario that included higher walls for that stacking facility for the 313. And so what we did is we created new scenarios, and we have adopted those, and they are available this year for contracting. So we have two scenarios, one's for less than 2K square feet and one's for larger than 2K square feet. And they both scenarios are based on having an 8 to 10 foot high wall as part of that stacking facility, an 8 to 10 foot high concrete wall. Sorry, let me clarify. So a question came up about these scenarios. What if the wall is buried 2 feet and 6 feet are extended above the finished floor elevation? There may be reasons to do that for the foundation and getting on a good soil foundation, and that makes sense. And if that's what we're doing, if we have 8 feet of vertical wall, a vault stem, then that would fit under this scenario. This would be the best fitting scenario. So this can be used if we have 2 feet of that wall buried and 6 feet sticking above ground. So once again, any questions, give a yell. Another new scenario, there was a request from Western PA where there are times a spring development goes in, but we don't need to install a collection box. Well, before this year, we didn't have that option to contract it that way. We only had the option with a collection box. And so we created a new scenario, and we now have a new spring development scenario where we're just collecting the water, but there's no collection box included. So I think, breeze through that. That's pretty self-explanatory. Another new scenario in Pennsylvania this year is the 587 structure for water control, concrete bottom level spreader. Some feedback we had was that we needed this, and it was being used as part of bunk silo, high flow, low flow systems, especially on the high flow end, to distribute that high flow water over a grassed area. And so we created the scenario, and that would be available for anyone who needs to use that as part of a bunk silo runoff system, or if there's another use for a conservation need. Okay, shifting gears away from programs, NRCS updates related to the engineering. And I wanted to highlight here partnerships. Denise Coleman, our state con, is big into partnerships, and she really supports partnering. And so wanted to highlight at this workshop that the NRCS chief visited in October, and during that October visit, a memorandum of understanding was signed between Penn State, the State Conservation Commission, our state agency, and NRCS. And with this MOU, the three parties were coming together to formalize a partnership that's really been going on for decades, where there's been good partnering happening. And so this helped to formalize that and to strengthen that partnership. Now, each party brings something to the table to support the group overall, and the group mutually agrees that technical assistance to implement conservation projects should be supported by all three and should be grown by all three. And so coordination by these three agencies or groups will serve Pennsylvania conservation professionals and landowners better and well. And the group believes that a technical assistance capacity can be grown, that there's a need to train staff well, and this group can do that better as a group, and that funding can be coordinated. There's a lot of funding coming from various sources, from the state, from NRCS, and locally and federally, and so coordinating funds as best possible to really serve our producers in Pennsylvania was something this group also agrees is critical. Now, a big part of this MOU and this partnership is the Center for Ag Conservation Training Center. Now, the state conservation has contracted through Penn State, and they are, my notes here say they're preparing to announce a contract with an engineering firm as part of this conservation center. But I saw a release early this morning, and actually an engineering firm has been noted, and that's on my next slide. So the SEC contracting through Penn State are going to have an engineering firm on staff to help build technical capacity in Pennsylvania for that partnership. Additionally, PA NRCS is committed to staffing this as well by providing a senior level engineer and a senior level ecological sciences employee in the future to coordinate with this center. Now, the MOU has many details that I won't go into, but the overarching message is that Penn State, the SEC, and NRCS are committing to work together to support each other, to support conservation, and to support technical assistance. And if you want to hear more about this, and even if you don't want to hear more about this, I would encourage you, I'm going to put a shameless plug in as well, come to NABEC, which is scheduled to be held at Penn State on July 14 to 17, and that would be the Northeast Agricultural Biological Engineering Conference, and really a great way to build partnership, which is what this slide is talking about. And I do have I will have a couple minutes as a part of a quick presentation to talk more about what Pennsylvania has done to partner and this MOU. So consider attending NABEC July 14 to 17, especially if you're an ag engineer or an engineer that's involved with conservation in the Northeast area. And you don't have to be an ASAB member to attend. So I know that's a question I had years ago, and you don't have to be an ASAB member, but you would need support from your supervisor. Okay, so I mentioned that there was a press release that a engineering firm was named by the State Conservation Commission, and that engineering firm is HRG, and they have been contracted to do that, and they're going to work to build technical capacity. Now, I don't have a link to the press release, but I just Googled the title here, and I was able to get several hits in Google from the Penn State website, the Penn State Extension website, and the HRG website that would provide this article. So if you're interested in reading that, I would encourage you to do it. So moving on with staffing updates within NRCS Pennsylvania, the first thing I want to mention is I said that we would be providing, a senior level engineer at some point to work with that center and the engineer that's been contracted. Well, it takes time for us to hire people. That's a long process. So Denise Coleman, our state con, has decided to do 120 detail, and Mark Buckwater is going to be serving on that detail to work with the State Conservation Commission and that Penn State engineering firm to coordinate how that is going to come together and some efforts that they're going to make to build technical capacity. So Mark's going to be serving on that detail, and he won't be working on the dam rehab watershed projects that he typically has been. And EWP, Mark Buckwater is our EWP program manager. That will continue, but we're going to try to relieve him of those duties as much as possible. Additionally, we have engineering vacancies across the state, and I just wanted to highlight, I believe I hit them all here. I just wanted to highlight several. We have 2 vacancies in Somerset, and those will be released, I think, within a couple weeks, and that's going out as a Pathways Recent Graduate announcement. And then 2 in Clarion, also Pathways Recent Graduate announcement. And what that Pathways Recent Graduate announcement means is a person doesn't have to have graduated to qualify for that position. They have to be graduating within a couple months, but a May graduate would be able to qualify for these vacancies if we have some people out there who are interested in applying. Additionally, one other requirement is that the person, if they have already graduated, it has to have been within 2 years of when the vacancy closes. So really trying to capture people that are pretty new out of college. Additionally, we have an engineering vacancy in Lebanon that's supposed to be going in as a 7-9-11 position, and that is to replace a vacancy that is there. We have another engineering vacancy. This is out of the state office. It's a structural engineer that's going to be re-advertised, and we're in talks about how best to do that. But we're really looking for a PE and someone with a strong structural background for that vacancy. And then Additionally, I had noted earlier that Paul Schaefer, our assistant state engineer, has decided to move on, so we'll have that vacancy coming out. That'll be later. That's not as far into the process, the hiring process, as some of the others, but we will be looking for an engineer out of the state office, likely out of the state office, and once again, really looking for a PE, someone with a strong ag background for that position. And then, as I mentioned, with the center and that partnership, we'll have the ag engineer for the partnerships that will work with the State Conservation Commission and Penn State. All right, continuing on. I say training opportunities, but I just wanted to note a couple of training things that are coming up. We're hitting our training season for PA NRCS, and many of you know that we offer the Ag Conservation Technical Assistance trainings. We like to call them the boot camps here, and we will have Boot Camp Basic. It's going to be held once April 8th to 12th. We're going to have a large group, and this information hasn't even gone out to the instructors yet. That just was decided this morning, so we are going to run boot camp once. We did have talks about running it twice. Last year, we ran it 3 times because there were so many hires within Pennsylvania, within NRCS, conservation districts, other partners that attend the boot camp. So we ran it 3 times last year, but this year we're down to one large group. We have a second session, Boot Camp 2, that is going to be run twice. It's going to be April 29 to May 3. And that training is broken into 2 different tracks. There's an engineering track and an agronomy track, and both tracks will participate that week. So we'll have a full group April 29 to May 3rd. And then there were so many applicants on the agronomy side this year wanting to attend Boot Camp 2 that we will be running a second week of agronomy only, May 13 to 17. So information that's going to go out to our instructors that are involved with boot camp here this week, but everyone on this training gets a heads up on that. Additionally, we're bringing in national instructors, or we're planning to bring in national instructors for the Concrete Fundamentals course. It's a great course talking about concrete, and that is scheduled for May 20 to 24 in Harrisburg. Now, national funding for the federal government could impact that. If travel is not allowed because we're on a continuing resolution, that will get postponed, but we're hoping that that can continue and that the federal employees will be funded with travel by May. I also wanted to say that we have a basic Civil 3D course that we internally have been running on an annual basis. Jared Boger will lead that along with help from several other really good CAD users in Pennsylvania, and that is scheduled for February 21 to 23. And I think he's got a full course at this point, but we will run that again when there's a need for more CAD training. Additionally, InfraWorks is scheduled. National instructors coming into Pennsylvania March 26 to 28. So we're excited about that. That also hinges on federal funding. So that could get postponed, but we're hoping that can happen. And that we haven't accepted registrations for that yet, so that will be coming. And I don't expect a ton of CAD users that are in the ag conservation field to really need InfraWorks, but this is something that might be useful for some of the larger watershed and dam rehab projects. We've got our Act 38 courses that are coming up this spring, and the one that engineering really helps out with a lot is the ACA and manure storage training. I think it's a great course that's scheduled for May 20 to 22 in Lewisburg. And if you haven't attended that, I would strongly recommend that you take that. Just going out to several sites, identifying ACAs. Is it an ACA? Is there an issue, a resource concern from that ACA? And then talking about ways that ACA could be addressed through conservation practices or management. So a great course there. We're bringing in national instructors for liner training, July 29 to August 2. So that would cover clay lined storages and also HDPE and other geosynthetic material liners. And we have, that goes along with the cover talk earlier. The same Pennsylvania contractor who does our HDPE liners would be doing the HDPE covers, and it makes sense to do those at the same time, as Jenny had mentioned. And then finally, NABEC. I mentioned it already, but please consider NABEC July 14 to 17. It's at Penn State. It rotates around each year to different states, and this year it's right here in the middle of Pennsylvania. So I hope everyone considers that. That's an engineer and involved with ag conservation. So with that, that's what I got. Any questions in the chat? Let me jump back. First question: can TSPs be notified when standards or specs are updated? Yes, and I need to do a photog bulletin, and I will do that once I mentioned I'm behind on getting them in. So I will do that once I get the last of the standards in. So good question, Mike. There will be a bulletin that goes out, and if you're on the PA NRCS newsletter that goes out each week, that bulletin would certainly be posted there, and you're being notified today. So thanks for being a part of the meeting here, Mike, and we would probably also talk about this again at our annual TSP workshop. Yeah, thanks, Dan. Bob, wow, VTA has always been 100 square feet, so you're maybe ahead of the game when it comes to Pennsylvania there. Oh, very good, Bob. Thanks for the reminder. Abstracts for NABEC. If you're willing to give a presentation or a poster presentation at NABEC, those abstracts are due Friday, so get that in, and definitely consider that. Pennsylvania, the way we handle it is if you give a presentation or a poster, you can get travel from the agency to attend, and if you don't, then that'd be on your own dime. But something to consider, and a great opportunity to hear what's going on within ag and biological engineering and other parts of the Northeast, and to do some networking, and just a great overall experience. So that's what I have. Any other questions before we wrap this up? Pretty close to what the agenda said. Once again, if you want PE credits, PDHs, please reach out to me. I will send those out probably within the week or so. And thank you, everyone who attended. And a big thanks to those who participated by presenting today. We greatly appreciate that. So thanks all, and have a great rest of your week.
Great job, Tim.